Today we looked at proportional and linear tables. So if we have tables and we're trying to figure out if they're proportional or not, then we pull back from our knowledge from seventh grade. So we learned that proportional relationships, we can use the equation y equals kx. And in those proportional relationships, every time we should be able to multiply x by k to get y. So if we're looking to figure out if something is proportional or not, we can look to find that k value, and we can do that by dividing y by x. So for this problem, that would be 5 divided by 2, 10 divided by 4, and 16 divided by 6. And then if we divide those, 5 divided by 2 is 2.5, 10 divided by 4 is also 2.5. And then 16 divided by 6 is not 2.5, it's 2.6 repeating. And so there is not a constant rate of change through there. There's not a consistent k value. So this one is not proportional. Okay. And then if we look at number 2, I can tell that it's proportional without necessarily having to look for k. So one place that I see it's not proportional is here in this first point. Remember, to be proportional, it has to pass through the origin, and it's also a straight line, so there's that constant rate of change. It doesn't pass through the origin, the point 0, 0. It passes through 0, 5. So for that graph, when x is 0, y is 5. So on the y-axis, we would see it starting at 5. Another thing that we noticed right here, if I multiply 2 by 2, I get 4. So then I would have to also be able to multiply 9 by 2, but 9 by 2 is 18, not 13, so that doesn't hold true. So we figured out in class today that number 2 is also not proportional. So being able to figure out if a table is proportional or not is one of the things that you need to be able to do. But there's something special about number 2. It's not proportional, but if we take a deeper look, from 0 to 2, like my x went up by 2. And from 5 to 9, my y went up by 4. And then from 2 to 4, my x increased by 2. From 9 to 13, my y increased by 4. So it is not proportional, but if we look at this, it does, like, there is a constant rate of change. Every time x is increasing by 4, or sorry, but every time x is increasing by 2, y is increasing by 4. So it's not proportional, but it is linear because there is a constant rate of change. And we could go a little further, and we could write a sentence as x increases by 2, y increases, I'm going to abbreviate that, by 4. And then one thing that we were looking at today is we used that to help us find the unit rate. So we scaled that down. So to be in a unit rate, we need to know what happens as x increases by 1. We need to figure out what happens to y. And so pulling back on our knowledge from our rate tables that you've made when you were in 6th and 7th grade and you were looking at proportional reasoning and your rates and ratios, I would have to divide by 2. 2 divided by 2 would give me 1. And so for the change in y, I would also have to divide by 2 to scale that down. And so as x increases by 1, y increases by 2, because 4 divided by 2 would give me 2 there, right? So every time x increases by 1, if we were on a graph, we're starting at 5, and if x increases by 1, my y is going to increase by 2. So there we see the unit rate showing up in the graph. X increases by 1, y is increasing by 2. And now we can see that straight line showing up in the graph. So when we're finding the unit rate from a table, we're actually going to look at this two ways. Today we're looking at sentences. Next class we're going to be looking at a different method. Our goal is to create a sentence that tells us what happens as x increases by 1. And this part that says that y increases or decreases by a certain number, that is going to give us our unit rate. It tells us how that graph would be changing every time x increases by 1. That is our unit rate. That is our m. So we have a different equation today. We've talked about y equals kx when it's proportional, and k is that unit rate. We've actually used this equation. This is called slope-intercept form. We're going to do more with it later. You guys have been writing equations like this. It says y equals mx plus b. So in the walkathon, we had a y equals 0.5x plus 5, where the person got $5 to begin with, and then they also got 50 cents per kilometer walked. So that m is just your unit rate, and that b is that starting value that we had to add in. So sometimes this constant rate of change that we saw in number 2, it's not quite as obvious. So for this example, if I look at my x's, from 3 to 6, that is an increase of 3. So we would start our sentence off with as x increases by 3. And then y went from 12 to 6. That went down 6, so we would put a negative 6. We would finish our sentence with y decreases by 6. And then for the second part of that table, from 6 to 10, that's an increase of 4. So we could write as x increases by 4, and then we are going from 6 to negative 2. So I would suggest if integers are ever tricky for you, think about it like a vertical number line or a thermometer. We went from 6, there's my 0 degrees, there's my negative 2 degrees. So from 6 to negative 2, that went down 8. So it decreased by 8. So these sentences aren't the same, but that doesn't mean that there's not a constant rate of change. What we have to do is find out what happens when x increases by 1. So if we were going to turn 3 into 1, we would have to divide by 3. So we also need to do the same thing with that change in y. We would divide it by 3. 3 divided by 3 is 1. Decreases is going to stay the same. 6 divided by 3 is 2. So we end up with the sentence that says, as x increases by 1, y decreases by 2. And then if we look at the second sentence, if we were trying to go from 4 to 1, we would have to divide by 4. So we would also have to divide the 8 by 4, and 8 divided by 4 is also 2. So both of those sentences, they both can be scaled down to the sentence as x increases by 1, y decreases by 2. So that's our sentence that states our unit rate. And the other thing that we would want to be able to do is to write our unit rate as a number. On a graph, every time x increases by 1, our y value is falling. It's decreasing by 2. So if we think about that on the graph, it's easy to see that it's falling. So this decreasing lets us know that we need to have a negative, and it's decreasing by 2, so my unit rate would be negative 2 for this problem. So you're going to follow these same steps that we did in this problem with our work on the table and our work with our sentences. You're going to do that for problems 1, 2, and 3 on task 1. So 1 and 2 are just like the problems that we just did. For number 3, I'm going to give you a hint. To figure out how much x increased by, you actually need to count those spaces on the graph, and then you would do the same thing to see how much y changed, and then you could use those values to write the sentence. So complete problems 1, 2, and 3, and then upload your work to Google Classroom. As always, reach out to me if you have any questions. Take care.